I just have two sets of parentheses where I have put moles of the known in the first one, and then I put the mole ratio. And remember the mole ratio, that's the one and only place you use coefficients. And the mole ratio is the coefficient of the unknown over coefficient of the known, United Kingdom. And if you do that, this gives us something about the unknown, but what are the units for the unknown with two sets of parentheses? Moles. That gives us moles of unknown. But if for some reason we want grams of unknown, we start out the same. We have moles of known, mole ratio. If you've got, let's go back to chapter 2 stuff. We did this in chapter 2. Let's pretend we're talking formulas only, or compounds only. If you had grams and you wanted to get here, what was it we did with the formula weight? Divide. And if we had moles, like we would here, and I want to run it backwards, we multiply. And so here we put formula weight of the unknown, and that switches you from moles of unknown to grams of unknown, and that's based on what you learned in chapter 2. Okay, now, there are various kinds of problems here, and let's make a list. When you're doing a weight, okay, here's my known category, here's my unknown. You can be given moles, and they ask for moles. Great. That's the easiest way to go. Or they can give you moles, and they ask for grams of unknown. Or they can give you grams of known and ask you for moles of unknown. Or the big time is they give you grams and they want grams. That's probably the most common, but what you have to be ever alert for is which is it they're giving you. Because you do different things depending upon what they're giving you and what they're asking for. So let's take a problem. I think it's the one we ended with last time. And let's take, in fact, let's just take a look at this one. And this is problem 3-5. Okay, now, let me change that up a little bit. What if I said, let's just do some practicing. Let's just do some really easy mole in our head. Okay, look up there. Every time I have 1 mole of methane, how many moles of oxygen do I need? 2. If I have 2 moles of methane, how many moles of oxygen do I need? 4. If I have a half a mole of methane, how many oxygens do I need? 1. Those are mole to mole. That's the first type. And if the numbers aren't too nasty, you can just do it in your head. Okay? Or what you were doing in your head is that first line up there. You were using the mole ratio to know what to multiply. Remember in weights, we deal just with 2 things at a time. They can be any 2 things, 2 products, 2 reactants, 1 product, 1 reactant, doesn't matter. They can tell you about a product and ask you about a reactant. Any combination is fair. Okay, I think this is where we ended. At least that's my note to myself up there in the corner. On the 17th, that's where we ended. So we have our balanced equation. Now, on the test, I would be really sure, do a little double check. Is it balanced? It should be balanced, but in case there's a typo that I haven't caught, that makes a big difference in your answer. So just do a little quick check. Is that balanced? Is it balanced the way it is, the equation?
Yes.
Yes. Okay, so that's an okay place. I didn't make any typos. Okay, now what it says there, how many grams of oxygen are required to react completely with 24 grams of methane? Okay, what's your unknown? The oxygen. In fact, let's write the equation up there. So we have methane plus oxygen gives us CO2 plus 2 waters. Now we could include states like this is a gas, this is a gas. That's just added information. It's not needed to do a problem like this. So, how many grams of oxygen? So let's put up here, X grams. That's our unknown. Okay, now you were told you have 24.0 grams of methane. So I always like to set these things up the very same way. Okay, I put info about my unknown above the unknown, info about my known directly above it. If you want to, label like I will here, which is which. And since we're talking grams, we're going to need formula weights. So for our formula weights, I put them down below the two things that I'm concerned with. And I want to emphasize the formula weight. Okay? I don't care if there's a 2 here or a 20. I want the formula weight of the O2. Okay, so we come over here. Now, formula weights, that came in chapter 2. What's the formula weight of this? Can you just do it in your head? Nina, what'd you get?
16.
Okay, and to the nearest tenth it would be?
Point
Just
zero.
Point zero. And what are the units on that formula weight? We no longer want AMUs, so we want to jack it up to what's
Grams per mole.
grams per mole. Good. Okay, now, I want the formula weight of this. And here's a tricky sticky point for some folks that have learned a different technique in high school. We're ignoring the 2 out front. Because in my method here, I use those coefficients here and nowhere else. So when I say I want the formula weight, I just want it O2. So Timothy, what will that be?
32.0
Give us some units.
grams per mole.
Grams per mole. Okay, so what do we have? We've got this type. They gave us grams, they're asking for grams. Okay, so that means if you're being asked for grams, that means the 3 sets of parentheses there, and that's going to give us grams of oxygen. Okay, so
The 16 grams per mole is just for carbon, right?
it's just for methane.
Methane.
Carbon is 12, if you look up there.
Right.
Carbon's 12, and then each hydrogen's 1. I got 4 of them, so 16 is where Nina got that for us. Okay, everybody up to speed this far? Okay, now, look at this. In previous problems, we were handed a gift. They just said, here are the moles. And we say, thank you very much, slapped it in. But now, they're giving us grams. So in this first set of parentheses, what are we going to do? What are we going to do? Tanya, what would you do?
24.0 grams over 16.0 grams per mole.
Very good. And it'd be also good to label stuff, because grams of methane can only cancel with grams of methane. Okay, and ultimately moles of methane can only cancel with moles of methane. Remember, this is a complex fraction. We were doing this in chapter 2. We were doing this kind of stuff all the time. Now, actually, in chapter 2, I sent that on to say number of molecules. But we don't do that much, because they're always huge numbers, and we're usually, our problems, after we get past chapter 2, is just whipping back and forth here. Okay, so what Tanya did for us here, she switched that into moles, because we didn't have moles already. So we had to divide by the formula weight to get there. Okay, then we want to use mole ratio here. Eddie, what's my mole ratio?
2/1.
2/1, good. And this is 2 moles of O2 over 1 mole of methane. Now, I know I look at my students, their papers, when they're working problems, The majority of them don't take the time to write this stuff down because, yeah, it takes time to do it. But it's your security, it's your insurance. Because here, moles of methane come up on top, moles of methane are on the bottom. So if we stopped after 2 sets of parentheses, we have moles of oxygen. Chris, you have a puzzled look on your face. Can you ask something?
I just need to see the whole process a couple times.
Okay. Repetition is good. That's one of the brain rules in that book on brain rules. Exercise is good. You need oxygen to the brain. But also repetition is very good. That's a whole other chapter in the book. Okay, so I've got moles of O2 and I want to crank it into grams of O2. Marco, what do I do?
The formula with the unknown, which will be times 32.
Yes, 32 grams per 1 mole of O2. Now look, moles of O2, cancel with moles of O2, that leaves grams of O2. There's your insurance policy. And the units came out okay. One of the biggest mistakes students make is to invert this thing. That's one big mistake they make. The other mistake they make is they'll try to put this as 32 times 2 and they'll put a 64 out here. But see, that would be using that 2 times. So if you're using this technique, only use your coefficients here. Okay, now let's multiply that through and let's think sig figs. Nicole in the back, what did you get? And while she's doing that, or do you have a number already? Don't look at my paper or the book. Okay, I'll saw you glance over there. Okay, while she's punching it through for us, if you are rusty on your calculator or you're scared, here's the safe route. Multiply 24 times 2, get an answer, times 32, get an answer, and write it down. Then, go through 16 times 1 times 1, write it down. Then you divide the bottom into the top. Okay, but if you're slick on your calculator, you could divide this, get an answer, take that times 2, get an answer, take that times 32, get an answer. You never have to stop and write it down. Now, did I give you enough time? Okay, hit it.
96 grams,
How about 6?
0.0.
Okay, is that what other folks got? Brittany, you look puzzled. You got a question?
Oh, okay, you said it, okay.
You're okay?
The UK part again.
Okay,
I understand, I think I get that there's 2 moles of oxygen. Is that,
okay.
you
So
know,
there's, every time, see this gives us, we've got how many moles we have. Every time I have a mole of methane, I need twice as many. So I put coefficient of the unknown, which is 2 in this case, over coefficient of the known. But if you're reasoning this through, like when I was running you through your paces up here, I say, I've got 1 mole today of this. How many moles of this do I need? And you all shouted 2. I said, I've got 2 moles of this. How many moles of this do I need? 4.
okay.
Twice as many. So if that's what you're doing here, is just the numbers. So you don't know immediately how many moles of this you got. Are we okay on that?